Hello, my name is Runa Chatterjee and today I will perform two different inferential tests of mean differences. Let us look at my data. We have Algebra 1 scores from 15 different students. The first measurement was done before those students started using TI-84 calculators. The second set of data was obtained from the same 15 students after they started using TI-84 calculators. Let's look at the research question. My research question here for paired samples t-test is, what effect does TI-84 calculator have on Algebra 1 scores for the freshman class at a local high school? Null hypothesis, there is no effect of TI-84 calculator on Algebra 1 scores for the freshman class at a local high school. Research hypothesis, there is a significant effect of TI-84 calculators on Algebra 1 scores for the freshman class at a local high school. Statistical test being performed is paired samples t-test, independent variable TI-84 calculators, dependent variable Algebra 1 scores, and we will measure the effect size by determining coherence D. So before we can go into finding t-value, we will do some descriptive findings here. We will find the average of the first group of scores. Similarly, we'll find the average of the second set of scores. So we have these two means here. Standard deviation of the first group. Standard deviation of the second group. And we can go ahead and convert these numbers into a little friendlier looking format. Number two decimal places is good. We have 15 students in both the set of data. Degree of freedom n-1 is 14. And now we are ready to calculate the t-value. So we will go to data analysis, we will find t-test paired two samples, variable 1 range are the scores before TI-84 calculators, variable 2 are scores after the use of calculators. Hypothesized mean difference, I want to write 0. There are no labels. Alpha is set to 0.05. Output range, let's select the cell. Okay. So we have a bunch of different numbers here and we will figure out the significance of these numbers. So we're looking all the way at the bottom. We have a t-stat score here, which I'm going to copy straight from here and put it in this box. Now I need to compare my t-value to the t-critical value. When we began this analysis, we did not assume that our scores would be better or worse because of TI-84 calculators. Therefore, I'm going to consider t-critical value of a two-tailed test. which is 2.14. P-value, once again, we will consider of a two-tailed test. Our alpha is 0.05. And once again, I would like to clean up these numbers a little bit. Now let us look at the two pieces of information that will help us decide whether we should reject or fail to reject our null hypothesis. So we're looking at t-value of 3.78. The negative value does not have any meaning here because it just means that we subtracted a higher mean from a lower mean. We are going to consider the absolute value of t and compare it to t critical. Since our t-value is higher than t critical, we are going to reject our null hypothesis. And the second piece of information that we have here is that our p-value is less than the significance level. The p-value was actually 0.002. I formatted the cells in such a manner so that we have 2 digits after the decimal, and hence we are not seeing 0.002. So p-value is less than 0.05. Therefore, we will once again reject our null hypothesis. What does that mean? So we have rejected that there is no effect of TI-84 calculator, which means there is a significant effect of TI-84 calculators on Algebra 1 scores. So our next step is to find out how big or how significant is this effect of TI-84 calculators on Algebra 1 scores. So we are going to make use of an online tool to calculate our Cohen's d, which will give us the effect size. So I'm simply going to copy my mean value into this box, mean 2 value into the second box, standard deviation, standard deviation 2, and then compute. The value of Cohen's d is 0.661. We will copy that down. 0.661. So what is the meaning of this effect size? This is definitely higher than 0.5, which means the effect size is little more than medium and it is less than large. So the Cohen's d, the effect size of 0.661 indicates that there is a substantial degree of significance of TI-84 calculators on the Algebra 1 scores, which means there is not a lot of overlap between the two distributions. Going back to our planning sheet, and we will quickly look at the assumptions that we made for our paired samples test. We assume that dependent variable is continuous, and they are because Algebra 1 scores are interval level measurements. Observations are independent of each other. One subject's scores were unrelated to another subject's scores. Dependent variables are approximately normally distributed. We found the variances of the two groups of scores and their ratio was less than 4. And dependent variable does not contain any outlier. That was revealed by plotting a scatter plot. We did not see any outlier points. So this was a paired samples t-test, and I chose this test because we are determining this data from the same set of people. We are testing them once before the use of TI-84 calculators, and we are testing them twice after the use of TI-84 calculators. Moving on to the second test, which is the unpaired t-test. The data I have here is daily average attendance in percent during the last grading cycle of the school year. And the two independent groups that I have this data from are group of students who are seniors and the other group of students who are not seniors. So the non-seniors could be freshmen, sophomores, juniors. So there are two independent groups, seniors and non-seniors. Let's look at the research planning sheet. The research question I have here is, what effect does senior and non-senior grade classification have on daily average attendance during the last grading cycle for students at a local high school? Null hypothesis: there is no effect of senior and non-senior grade classification on daily average attendance during the last grading cycle for students at a local high school. Research hypothesis: there is a significant effect of senior and non-senior grade level classification on daily average attendance during the last grading cycle for students at a local high school. The name of the test that I will run is called Independent Samples T-Test. Independent variable, senior and non-senior grade classification. Dependent variable, average daily attendance during the last grading cycle. And once again, the effect size will be calculated by using Cohen's d. We will once again find some descriptive aspects of the two sets of data. Now this time, I am going to simply run a descriptive analysis so that I find all of my values all at the same place. Input range. Summary. So I will just go ahead and copy my data into here. We have 15, the count is 15, and our degree of freedom here would be n plus n1 plus n2 minus 2. Now, we do not need any of these numbers, so I'm going to delete and clear some space. Okay, and now I'm ready to run my t-test. So we will go to data, data analysis. Let's find the independent test. We are going to run two sample assuming equal variances. Variable 1 range, variable 2 range. Hypothesized mean difference is 0, alpha 0.05, output range can be here. Okay, so we have a couple of important values which we will try to interpret. So once again, we did not start off assuming that one grade level attendance is going to be higher than the other. Therefore, I'm going to, first of all, copy my t-stat value here and then compare it to t-critical of a two-tailed test. p-value for a two-tailed test is this. Alpha value is 0.05. I'm going to make use of Cohen's d online calculator once again to find my effect size. So mean 1, mean 2, standard deviation 1, standard deviation 2, compute, and now I have an effect size, a very large effect size, close to 1 actually. And I'm going to clean up these values a little bit so they look uniform. We want 2 decimal places. All right. Let's try to make sense of these values. So we have t-stat value of 2.58. Once again, we will ignore the negative sign and take the absolute value of 2.58, which is larger than the t-critical value of 2.05. That indicates that we have rejected the null hypothesis. Since t-stat value is greater than t-critical, we reject the null hypothesis. Again, p-value 0.02 is also less than the level of significance, which is 0.05. This is the second reason why we will reject the null hypothesis. So if we reject the null hypothesis, it means that we are rejecting the fact that there is no effect of senior and non-senior grade classification. We are saying instead, we are making an inference that there is a significant effect of senior and non-senior grade classification on daily average attendance during the last grading cycle for students at a local high school. Now we have determined that this is significant, but how significant? Let's look at the effect size. The effect size is 0.94, which is very close to 1. So this is a very high effect size. What does that mean? That means that the two distributions are almost 1 standard deviation apart from each other. They are 0.9 standard deviations apart from each other, which means there is a negligible overlap between the two distributions. So going back to the research sheet now, we will look into the assumptions that we made very quickly. So the first assumption was the assumption of independence. Senior and non-senior grades are 2 independent categorical groups. Second, assumption of normality. Our daily average attendance was normally distributed, and the assumption of homogeneity of variance. The variance of dependent variable, which is the daily average attendance, was approximately equal for both the groups. The reason we chose independent tests for this set of data is because we have 2 independent groups and there was 1 dependent variable, and we measured that we took data from these 2 independent groups 1 time for that same dependent variable. This is the end of my video.